Statistics. Like most people, you probably feel that it is important to take control of your life. But what does this mean? Partly, it means being able to properly evaluate the data and claims that bombard you every day. If you cannot distinguish good from faulty reasoning, then you are vulnerable to manipulation and to decisions that are not in your best interests. Statistics provides tools that you need in order to react intelligently to information you hear or read. In this sense, statistics is one of the most important things that you can study. To be more specific, here are some claims that we have heard on several occasions. We are not saying that each of these claims is true. 4 out of 5 dentists recommend Dentine. Almost 85% of lung cancers in men and 45% in women are tobacco-related. Condoms are effective 94% of the time. Native Americans are significantly more likely to be hit crossing the streets than are people of other ethnicities. People tend to be more persuasive when they look others directly in the eye and speak loudly and quickly. Women make 75 cents to every dollar a man makes when they work the same job. A surprising new study shows that eating egg whites can increase one's lifespan. People predict that it is very unlikely there will ever be another baseball player with a batting average over 400. There is an 80% chance that in a room full of 30 people that at least 2 people will share the same birthday. 79.48% of all statistics are made up on the spot. All of these claims are statistical in character. We suspect that some of them sound familiar. If not, we bet that you have heard other claims like them. Notice how diverse the examples are. They come from psychology, health, law, sports, business, etc. Indeed, data and data interpretation show up in discourse from virtually every facet of contemporary life. Statistics are often presented in an effort to add credibility to an argument or advice. You can see this by paying attention to television advertisements. Many of the numbers thrown about in this way do not represent careful statistical analysis. They can be misleading and push you into decisions that make you find cause to regret. For these reasons, learning about statistics is a long step towards taking control of your life. It is not, of course, the only step needed for this purpose. These chapters will help you learn statistical essentials. It will make you into an intelligent consumer of statistical claims. You could take the first step right away. To be an intelligent consumer of statistics, your first reflex must be to question the statistics that you encounter. The British Prime Minister, Benjamin Disraeli, famously said, "There are 3 kinds of lies: lies, damned lies, and statistics." This quote reminds us why it is so important to understand statistics. So let us invite you to reform your statistical habits from now on. No longer will you blindly accept numbers or findings. Instead, you will begin to think about the numbers, their sources, and most importantly, the procedures used to generate them. We have put the emphasis on defending ourselves against fraudulent claims wrapped up as statistics. Just as important as detecting the deceptive use of statistics is the appreciation of the proper use of statistics. You must also learn to recognize statistical evidence that supports a stated conclusion. When a research team is testing a new treatment for a disease, statistics allows them to conclude based on a relatively small trial that there is good evidence their drug is effective. Statistics allowed prosecutors in the 1950s and 60s to demonstrate racial bias existed in jury panels. Statistics are all around you, sometimes used well, sometimes not. We must learn how to distinguish the 2 cases. Populations and samples. Before we begin gathering and analyzing data, we need to characterize the population we are studying. If we want to study the amount of money spent on textbooks by a typical first-year college student, our population might be all first-year students at your college, or it might be all first-year community college students in the state of Washington, all first-year students at public colleges and universities in the state of Washington, all first-year students at all colleges and universities in the state of Washington, all first-year students at all colleges and universities in the entire United States, and so on. Population. The population of a study is the group the collected data is intended to describe. Sometimes the intended population is called the target population. Since we design our study badly, The collected data might not actually be representative of the intended population. Why is it important to specify the population? We might get different answers to our question as we vary the population we are studying. First-year students at the University of Washington might take slightly more diverse courses than those at your college. And some of these courses may require less popular textbooks that cost more. Or on the other hand, the university bookstore might have a larger pool of used textbooks, reducing the cost of these books to the students. Whichever the case, and it is likely that some combination of these and other factors are in play, the data we gather from your college will probably not be the same as that from the University of Washington. Particularly when conveying our results to others, we want to be clear about the population we are describing with our data. Example 1. A newspaper website contains a poll asking people their opinion on a recent news article. What is the population? While the target intended population may have all been people, the real population of the survey is the readers of the website. If we were able to gather data on every member of our population, say the average, we will define average more carefully in a subsequent section. Amount of money spent on textbooks each first-year student at our college during the 2009 to 2010 academic year, the resulting number could be called a parameter. A parameter is a value, average, percentage, etc., calculated using all the data from a population. We seldom see parameters. However, since surveying an entire population is usually very time-consuming and expensive, unless the population is very small or we already have the data collected. Census. A survey of an entire population is called a census. You are probably familiar with two common censuses. The official government census that attempts to count the population of the U.S. every 10 years, and voting, which asks the opinion of eligible voters in a district. The first of these demonstrates one additional problem with the census: the difficulty in finding and getting participation from everyone in a large population, which can bias or skew the results. There are occasionally times when a census is appropriate, usually when the population is fairly small. For example, if the manager of Starbucks wanted to know the average number of hours per employees that worked last week, she would be able to pull up payroll records or ask each employee directly. Since surveying an entire population is often impractical, we usually select a sample to study. Sample. A sample is a smaller subset of the entire population, ideally one that is fairly representative of the whole population. We will discuss sampling methods in greater detail in a later section. For now, let us assume that samples are chosen in an appropriate manner. If we survey a sample, say 100 first-year students at your college, and find the average amount of money spent by these students on textbooks, the resulting number is called a statistic. A statistic is a value, average, percentage, etc., calculated using the data from a sample. Example 2. A researcher wanted to know how citizens of Tacoma felt about a voter initiative. To study this, she goes to Tacoma Mall and randomly selects 500 shoppers and asks them their opinion. 60% indicate they are supportive of the initiative. What is the sample and population? Is the 60% value a parameter or a statistic? The sample is the 500 shoppers question. The population is less clear. While the intended population of this survey was Tacoma citizens, the effective population was mall shoppers. There is no reason to assume that 500 shoppers question would be representative of all Tacoma citizens. The 60% value was based on the sample, so it is a statistic. Categorizing data. Once we have gathered data, we might wish to classify it. Roughly speaking, data can be classified as categorical data or quantitative data. Quantitative and categorical data. Categorical qualitative data are pieces of information that allow us to classify the objects under the investigation into various categories. Quantitative data are responses that are numerical in nature and with which we can perform meaningful arithmetic calculations. Example 3. We might conduct a survey to determine the name of the favorite movie that each person in a math class saw in a movie theater. When we conduct such a survey, the responses would look like Finding Nemo, The Hulk, or Terminator 3, Rise of the Machines. We might count the number of people who give each answer, but the answers themselves do not have any numerical values. We cannot perform computations with an answer like Finding Nemo. This would be categorical data. Sampling methods. As we mentioned in a previous section, the first thing we should do before conducting a survey is to identify the population that we want to study. Suppose we are hired by a politician to determine the amount of support he has among the electorate should he decide to run for another term. What population should we study? Every person in the district? Not every person is eligible to vote, and regardless of how strongly someone likes or dislikes the candidate, they don't have much to do with him being reelected if they are not able to vote. What about eligible voters in the district? That might be better, but if someone is eligible to vote but does not register by the deadline, they won't have any say in the election either. What about registered voters? Many people are registered voters but choose not to vote. What about likely voters? This is the criteria used in much political polling, but is sometimes difficult to define a likely voter. Is it someone who voted in the last election, in the last general election, in the last presidential election? Should we consider someone who just turned 18 a likely voter? They weren't eligible to vote in the past, so how do we judge the likelihood that they will vote in the next election? In November 1998, former professional wrestler Jesse "The Body" Ventura was elected governor of Minnesota. Up until right before the election, most polls showed he had little chance of winning. There were several contributing factors to the polls not reflecting the actual intent of the electorate. Ventura was running on a third-party ticket, and most polling methods are better suited to a two-candidate race. Many respondents to polls may have been embarrassed to tell pollsters that they were planning to vote for a professional wrestler. The mere fact that the polls showed Ventura had little chance of winning might have prompted some people to vote for him in protest to send a message to the major party candidates. But one of the major contributing factors was that Ventura recruited a substantial amount of support from young people, particularly college students who had never voted before and who registered specifically to vote in the gubernatorial election. The polls did not deem these young people likely voters, since in most cases, young people have a lower rate of voter registration and a turnout rate for elections, and so the polling samples were subject to sampling bias. They omitted a portion of the electorate that was weighted in favor of the winning candidate. Sampling bias. A sampling method is biased if every member of the population doesn't have equal likelihood in being in the sample. So, even identifying the population can be a difficult job. But once we have identified the population, how do we choose an appropriate sample? Remember, although we would prefer to survey all members of the population, this is usually impractical unless the population is very small. So we choose a sample. There are many ways to sample a population, but there's one goal we need to keep in mind. We would like the sample to be representative of the population. Returning to our hypothetical job as a political pollster, we would not anticipate every accurate result if we drew all of our samples from among the customers at Starbucks, nor would we expect that a sample draw entirely from the membership list of the local Elks Club would provide a useful picture of district-wide support for our candidate. One way to ensure that the sample has a reasonable chance of mirroring the population is to employ randomness. The most basic random method is simple random sampling. Simple random sample. A random sample is one in which each member of the population has an equal probability of being chosen. A simple random sample is one in which every member of the population in any group of members has an equal probability of being chosen. Sampling variability. The natural variation of samples is called sampling variability. This is unavoidable and expected in random sampling, and in most cases is not an issue. Stratified sampling. In stratified sampling, a population is divided into a number of subgroups or strata. Random samples are then taken from each subgroup with sample sizes proportional to the size of the subgroup in the population. Quota sampling. Quota sampling is a variation on stratified sampling, wherein samples are collected in each subgroup until the desired quota is met. Cluster sampling. In cluster sampling, the population is divided into subgroups, clusters, and a set of subgroups are selected to be in the sample. Systematic sampling. In systematic sampling, every nth member of the population is selected to be in the sample. Convenient sampling and voluntary response sampling. Convenient sampling is samples chosen by selecting whoever is convenient. Voluntary response sampling is allowing the sample to volunteer. How to mess things up before you start. There are a number of ways that a study can be ruined before you even start collecting data. The first we have already explored, sampling or selection bias, which is when the sample is not representative in the population. One example of this is voluntary response bias, which is bias introduced by only collecting data from those who volunteer to participate. This is not the only potential source of bias. Sources of bias: sampling bias, when the sample is not representative of the population; voluntary response bias; self-interest study; response bias; perceived lack of anonymity; loaded questions, non-response bias, and experiments. So far, we have primarily discussed observational studies, studies in which conclusions would be drawn from observations of a sample or the population. In some cases, these observations might be unsolicited, such as studying the percentage of cars that turn right at a red light even when there is no turn red sign. In other cases, the observations are solicited, like a survey or a poll. In contrast, it is common to use experiments when exploring how subjects react to outside influence. In an experiment, some kind of treatment is applied to the subjects and the results are measured and recorded. Observational studies and experiments. An observational study is a study based on observations or measurements. An experiment is a study in which the effects of a treatment are measured. Confounding. Confounding occurs when there are two potential variables that could have caused the outcome and it is not possible to determine which actually caused the result. Control group. When using a control group, the participants are divided into two or more groups, typically a control group and a treatment group. The treatment group receives the treatment being tested. The control group does not receive the treatment. Placebo effect. The placebo effect is when the effectiveness of a treatment is influenced by the patient's perception of how effective they think the treatment will be. So as a result, it might be seen even if the treatment is ineffectual. Placebo and placebo-controlled experiments. A placebo is a dummy treatment given to control for the placebo effect. An experiment that gives a control group a placebo is called a placebo-controlled experiment. Blind studies. A blind study is one in which the participant does not know whether or not they are receiving the treatment or a placebo. A double-blind study is one in which those interacting with the participants don't know who is in the treatment group and who is in the control group.